On March 4th, 2026, a woman pulled a brand new Toyota RAV4 into my bay with just over 51,000 miles on the odometer. She had owned it less than 2 years. She was not angry. She was not panicking. She was confused in that specific, quiet way that tells me the situation had already been explained to her by someone else, and it did not make sense. The dealership had quoted her a little over $3,200. They used words like premature wear, manufacturing variance, and recommended service interval. She handed me the printout and stood back like she was waiting for me to confirm that this was just the way things were now. I read the quote. I set it down. And then I told her something she clearly was not expecting to hear. This is a known issue. It has been documented. It has a cause, and most of it is preventable. Today, I am going to explain exactly why 2026 Toyota engines are showing up in shops before 50,000 miles with symptoms that look like advanced wear, why it is happening earlier than most people expect, and what the specific habits are that either accelerate the damage or stop it completely. This is not a scare video. I am not here to tell you your Toyota is a lemon. Toyotas are still among the most reliable vehicles on the planet. But reliability is not a guarantee. It is a result. And what I am seeing come through my shop right now tells me that a large number of drivers are doing something specific that is working directly against the engine's design. The symptoms are always described the same way: a slight roughness at idle that was not there before, oil consumption that seems higher than it should be for this mileage, sometimes a faint ticking or a cold start noise that fades after a minute. Nothing dramatic, nothing that sets off a check engine light immediately, just a quiet erosion of the smoothness that made the car feel premium in the first place. By the time most drivers notice it, the internal wear has already been happening for months. Here is what you need to understand about modern Toyota engines specifically. The 2026 model lineup across the RAV4, Camry, Highlander, and Tacoma platforms uses a refined version of the dynamic force engine architecture. This engine family is genuinely impressive. It achieves thermal efficiency numbers that would have seemed impossible a decade ago. It is designed to respond quickly to changes in driving conditions, manage oil pressure precisely, and use direct injection to extract every last bit of energy from the fuel. But that precision is also the vulnerability. When the conditions Toyota engineered this engine to operate under are not met, the wear curve accelerates, not catastrophically, not all at once, just steadily, quietly, and expensively. The first thing I want to explain is what is actually wearing inside these engines before 50,000 miles. It is not a defective part. It is not a design flaw in the traditional sense. It is a lubrication timing problem, and it is caused by a combination of 3 things that happen to align in how most American drivers use their vehicles: short trips, modern oil confusion, and what I call the warm-up myth. Let me start with short trips, because this one is more damaging than almost any other factor. A modern Toyota dynamic force engine reaches full operating temperature at roughly 195 to 200 degrees Fahrenheit. At that temperature, the tolerances inside the engine are exactly what the engineers designed for. The oil viscosity is correct. The clearances between moving parts are exactly right. The rings seal the combustion chamber properly. The cam lobes and lifters operate inside the oil film they were designed to ride on. But on a cold start, before that temperature is reached, every single one of those tolerances is slightly off. The clearances are tighter than spec. The oil is thicker than ideal. The ring seal is not perfect. And every time a cold engine is started and driven only 2, 3, or 4 miles before being shut off, it never finishes the warm-up cycle. It just gets partway there. Deposits form. Moisture that should have burned off stays in the oil. Combustion byproducts accumulate in places they are not supposed to accumulate, and then the engine cools down, and the whole process starts over. This is not new information, but what is new is how this engine specifically reacts to it. The dynamic force architecture uses an extremely tight piston-to-wall clearance to achieve its efficiency numbers. That precision is a feature in normal operating conditions. Under repeated incomplete warm-up cycles, it becomes a liability. The piston rings do not fully seat. Oil works past them. Combustion gases contaminate the crankcase. The oil degrades faster than the change interval assumes. And inside the cylinder walls, micro-scratches begin to form. I have seen cylinder walls in these engines at 47,000 miles that look like engines with 110,000 miles. Not because the driver did anything reckless, because the driver did short trips, changed the oil every 10,000 miles like the display said, and never thought twice about it. That brings me to the second factor, modern oil confusion. Toyota currently recommends 0W16 oil for some dynamic force engines and 0W20 for others. These are extremely thin oils by historical standards. They were specified because thin oil reduces internal friction, and that improves fuel economy, which helps Toyota hit its EPA ratings. In a fully warmed engine running at optimal temperature, 0W16 does exactly what it is supposed to do. It flows instantly. It coats surfaces before friction begins. It reduces drag. But in a cold engine, in an engine that only runs short trips, or in an engine where oil temperature never fully stabilizes, thin oil has less protective film strength. It does not form the same boundary layer under load that heavier oils historically did. When drivers use the wrong specification, for example, 0W20 in an engine specified for 0W16, or worse, a heavier oil chosen out of habit, the clearances that were engineered around a specific viscosity no longer match. Pressure becomes uneven. Coverage is incomplete. Wear accelerates in the very areas Toyota designed to be most precise. I want to pause here, because I know what some of you are thinking. You are thinking that Toyota has been making reliable engines for decades, and that this sounds like overthinking. And you are partially right. Most Toyotas survive owner mistakes for a long time. That is part of their reputation. But the dynamic force engine is not your father's 2GR FE. It is a purpose-built efficiency engine with tolerances and oil specifications that are not forgiving of deviation. Treating it like a 2009 Camry with a cast-iron engine is exactly the kind of habit that produces a quote for $3,200 at 51,000 miles. The third factor is what I call the warm-up myth, and it works in the opposite direction from short trips. While short trips never let the engine finish warming up, the warm-up myth is the belief that you should sit in your driveway idling for 5 minutes before driving on a cold morning. That habit predates fuel injection. It made sense for carbureted engines that needed time to stabilize fuel delivery. Modern fuel-injected, direct injection engines do not need it. In fact, for the dynamic force engine specifically, extended cold idling is one of the fastest ways to cause the very wear people are trying to prevent. Here is why. At idle, oil pressure in this engine is lower than under light load. The direct injection system sprays fuel directly into the combustion chamber under extreme pressure, and it creates a washing effect on the cylinder walls when combustion temperatures are below the threshold for complete fuel vaporization. Raw fuel contacts the cylinder wall. It strips away the oil film, and when the oil film is gone, even briefly, the piston rings begin to wear against bare metal. This effect is well documented. Toyota's own engineering documentation acknowledges that low-speed cold operation increases cylinder wall fuel dilution. The fix is not to idle. The fix is to start the engine, let it run for no more than 30 to 45 seconds, and then drive gently. Light throttle, low RPM, no aggressive acceleration for the first 2 to 3 minutes. That is what moves warm coolant and oil through the system efficiently. That is what brings the engine to operating temperature correctly. Idling does not do it. Idling just extends the damage window. Now, I want to talk about the direct injection carbon deposit problem, because this is the one that tends to produce the highest repair quotes and the most confusion. Every direct injection engine accumulates carbon deposits on the intake valves over time. In port-injected engines, fuel washing the back of the intake valve keeps deposits from building. In direct injection systems, fuel never touches the intake valve. Oil vapor from the crankcase ventilation system does. Without the cleaning effect of fuel, that oil vapor bakes onto the back of the valve and slowly builds into a carbon shell. Toyota knows this. Every automaker using GDI knows this. Most manufacturers have moved to a dual injection system that uses both port and direct injection to address the issue. Several 2026 Toyota models do use this dual injection approach specifically because of this problem, but not all of them. Even on the dual injection variants, the carbon accumulation problem is slowed, not eliminated. What accelerates it is the same short trips pattern I described earlier. Short trips mean the engine never fully reaches the temperature where combustion is clean and complete. Incomplete combustion produces more blow-by. More blow-by means more oil vapor entering the intake system. More oil vapor means more material available to bake onto the intake valves. Drivers who do consistent short trips are feeding the carbon problem 3 times faster than highway drivers. The symptoms are a slightly rough idle, a hesitation at low revolutions per minute, and a gradual loss of fuel economy that feels like the car is just getting older. By the time a scan tool reveals the problem, the deposits are substantial. The cleaning procedure, either walnut blasting or chemical intake cleaning depending on the engine, costs real money. On engines where the carbon has reached the point of affecting the valve seal, the repair bill climbs considerably higher. Here is what you can do, and I mean starting right now before you ever see a warning light. Get the oil specification right and stick to it. Look at the oil filler cap on your specific 2026 Toyota. It specifies the exact viscosity. Use that grade from a brand Toyota has validated. Do not improvise and do not use what is on sale. This engine's precision is not compatible with casual oil selection. Shorten your oil change intervals if you do short trips. The oil life monitor in these vehicles uses an algorithm that assumes a mix of driving conditions. If you are primarily doing city driving, cold starts, and trips under 5 miles, your oil is degrading faster than the algorithm assumes. Change at 5,000 miles maximum if short trip driving describes your routine. That is a small cost compared with a large repair. Extend your trips intentionally once a week. This sounds almost too simple to matter, but it is one of the most effective things you can do. Once a week, take your Toyota on a drive of at least 20 minutes at highway or steady-state speed. Let the engine fully heat soak. Let the oil reach temperature. Let the combustion cycle clean the chambers properly. This weekly habit alone dramatically slows carbon accumulation and oil degradation. Stop the long, cold idle. 30 to 45 seconds maximum, then drive gently. That is it. That is the correct warm-up procedure for this engine. Use a quality EA-based fuel system cleaner every 7,000 to 10,000 miles. Not as a repair when something goes wrong, but as routine maintenance that keeps the injectors and intake system clean before deposits harden into problems. The direct injection system in these engines is operating at pressures around 2,900 pounds per square inch. The spray holes are microns wide. Contamination that would be irrelevant in an older engine matters enormously here. The woman with the RAV4 and a $3,200 quote drove away without authorizing a single repair. We talked for 30 minutes. She understood the issue. She understood her driving patterns were the cause. She changed her oil that week with the correct specification. She committed to one weekly highway run. She bought a quality cleaner for her next fill-up. That is not a repair. That is a relationship with a machine that was engineered to last by a manufacturer with a century of intent behind every tolerance they specified. The 2026 Toyota engine failing at 50,000 miles is not really a Toyota problem. It is a usage problem meeting a precision design. The engine performs exactly as it was designed when it is used as designed. The drivers who understand that will be the ones driving past 200,000 miles, still talking about how reliable their Toyota is. And the drivers who do not understand it will be the ones handing over printouts in parking lots, confused about why precision costs so much when it fails. If this gave you something to think about, leave a comment with your mileage and whether you have started noticing any of these symptoms. The early ones are quiet. Most people miss them. Subscribe if you want to keep getting this kind of information, because the next video covers another common maintenance assumption that is silently damaging modern engines in ways that will not show up in your maintenance record until it is too late.